Okay, welcome, ladies and gentlemen. We are now getting into our final phase where we're talking about the final. This is again a replacement, but so as we go through this process, it's basically going to deal with all the things we talked about over the whole semester. So let's start with number one. So it says solve the following quadratic equation using the quadratic formula. So remembering that our quadratic formula is y equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so what we have to do is, first of all, make sure all letters and numbers are on the same side. So we need to move this 5p over, make it negative. I'm going to kind of come over this way. It says 6p squared minus 5p equals 14. Then I'm subtract 14 from both sides. And finally wind up with 6p squared minus 5p minus 14 equals 0. So now that all my numbers and letters are on the same side, I'm going to label them A, B, and C. So 6 is A, negative 5 is B, and C is negative 14. So now I plug into the formula that I wrote at the top, and it's going to be negative 1 times negative 5 plus or minus square root of negative 5 squared minus 4 times 6 times negative 14. And that's all going to be over 2 times 6. All right, so let's go and start simplifying. Negative 1 times negative 5 gives me positive 5, and then plus or minus, and then inside the square root, it's going to be negative 5 squared is 25, and then negative 4 times 6 is negative 24, and then negative 24 times negative 14 is positive 336. Okay, and that's all going to be over 12. So I'm going to add 12 plus, I'm going to add 336 plus 25, you get 361. So that's going to be 5 plus or minus the square root of 361 over 12. Well, first of all, we want to see if 361 is a perfect square. So we find the square root of 361, which comes out to be 19. So that means it's going to be 5 plus or minus 19 over 12. So remember, we got to split this up into two different answers. We're going to say 5 plus 19 over 12 and 5 minus 19 over 12. So 5 plus 19 is 24 over 12, which simplifies to just 2. All right, on this one, we have 5 minus 19. That's going to become negative 14 over 12, which we're going to leave as a fraction. And that's going to give us negative 7 over 6. All right? So the only option that has that is option C. It says, which of the following shows all the zeros for the polynomial function? So basically it just means that we have to find all the x-intercepts for this. So what you're going to do is you're going to go to Desmos. So give me 1 second to go to Desmos. And then we're going to type in the function again without the 0. So we're going to say 3x to the third, 3x, and then we're going to do to the third, minus 4x to the second, sorry, plus 4x to the second, sorry. Let's change this to a plus. Then minus 4. Sure we got it right? Yeah, 4x. Sorry about that. So it should be 4x. All right, so here, once we do that, we notice all of our x-intercepts is 1 here, 1 here, and 1 here. So we have negative 2, 0.6, 6, 7, and 0. So then we come back to our problem, and we find the one that has 0, 2 over 3, and negative 2. So that's going to be option B.
Excuse me, I need Lexi Delbray to attend this design out.
Okay.
Thank you.